Hi friends, now I am going to explain about the synthesis of some of the compounds by combinatorial method. First, we are discussing the synthesis of one comma 4 benzodiazepine 2-one. Synthesis of 1,4 benzodiazepine 2-one by combinatorial method. For this, we are taking the tentazyl resin. This tentazyl resin is tentazyl resin is formed by the attaching of polyethylene glycol molecules. The polyethylene glycol attached to the cross-linked styrene molecules, and this tentazyl resin is simply we can write as the active functional group will be hydroxyl group, and this tentazyl resin we are taking a starting material, the substrate molecule as aromatic ketone compound. This is NH F mark. This is a protected group. This protected amine group of this aromatic ketone compound. First, the substrate molecule is bound to the resin bead, or X. Here X may be hydroxyl functional group or acid functional group. With this is NH F mark. Here this is CO. This is AR. This tentazyl resin is bound to this substrate molecule. Now this is called as resin bounded substrate. Resin bounded substrate. And this substrate molecule, resin bounded substrate molecule, first doing the deprotection by using of 5-pyridine. The presence of 5-pyridine, followed by treating this one R1 NH F mark. This or bounded resin. This is first by the deprotection. This F mark protected group is deprotected, and followed by the treating with this substrate molecule. A loss of HF and producing this substrate molecule is added to this one FO R1. This is NH F mark. The next, the second step, again deprotection, and here the presence of acetic acid. This is for the cyclization, or so NHCO, this is R1, here this is AR, here with the deprotection this FMOC protecting group is deprotected and producing the NH2. In the presence of acetic acid, the cyclization is possible by the loss of water molecule and producing a double bond. This is N. This is R1. With this 1, 2, 3, 4, 5, 6, 7 membered ring is formed here by cyclization. Now this is treated with presence of base and followed by reacting with the alkyl iodide. In the presence of base, this proton is lost, this base attracts the proton and this or here N is attached to the R double dash, loss of HI, CO, this is R1, here M double bond, sorry, AR double bond N of this. And next, the presence of TFA, the trifluoroacetic acid, for the cleaving of this resin beach. Or X N R double dash AR double one N CO, this is R, this is 1, 2, 3, 4, 1, 4 benzodiazepine 2 ohm. With respect to this 1, 2, 3, 4 numbering, 1, 4 benzodiazepine 2 ohm. And here by variation at different substrate molecules and different aromatic keto compounds, and taking the here variation of different substrate second molecules and variation of these alkyl halides are producing a more number of compounds, a more number of benzodiazepine derivatives are producing. Second example, synthesis of quinolones. And this process is done by a chemical company, this is Park Davis. And for this, we are taking the Wang resin. Already we discussed the Wang resin. Simply I am writing this Wang resin OH, and this Wang resin attached to the bonded to This is 1, 2, 3, 4, 5, 2, 4, 5, trifluoro benzoyl. This is benzoyl group, benzoyl acetic acid. And first to the substrate molecule, this van resin is bonded. With this we get the resin bonded substrate molecule. Loss of water molecule here. I am writing this resin bead. This is a resin bonded substrate molecule. Now this way treated with DMF and dimethyl acetal. DMF and dimethyl acetal for the formylation reaction. In the presence of treated dimethyl formamide followed by dimethyl acetal for the formylation. The formylation is possible here. Here formal group is added, the formylation. After this is being treated with RNH2. Here by treating here by the loss of water molecule minus of H2O. Here the hydroxyl group is formed, and from here hydrogen, this OH group will be, whether is total water molecule is lost from there and producing CO, this is O, resin bonded. Here double bond of NH or here in the presence of DMG, dimethyl guanidine, trimethyl guanidine. Here cyclation is possible. F here N or O resin bonded. And here the presence of TFA, trifluoroacetic acid, to clear the resin bead. N or here COOH. If in this molecule, if R group is cyclopropyl group, the compound is ciprofloxacin. If R group is ethyl substitution, ethyl group, ethyl, that is norfloxacin drug. This by changing the substitution here, is by taking of these different amines, we get the different drug molecule. One is ciprofloxacin and second one is norfloxacin. Next, Next we are discussing by Suzuki coupling. Suzuki coupling reaction. For this we are taking the resin bonded. I'm taking the resin bonded this is aryl halides. The Suzuki coupling reaction is aryl halides treated with boronic acid. This is aryl boronic acid we are taking here. This is aryl boronic acid. Aryl halides in the presence of aryl boronic acid. Boronic acid in the presence of palladium catalyst and palladium 0 catalyst. Here is a resin bonded. And this is the loss of air attached to this CHO. Now photo desilylation. This big remote and producing CHO. This Suzuki coupling reaction is a CC bond reaction. CC bond formation reaction. Here, this resin bonded aryl halides when treated with aryl boronic acid in the presence of palladium catalyst, producing the CC bond is forming here. Next, by Stille coupling. This is also a CC bond formation reaction. Here we are taking a resin bonded aryl halides when treated with tetramethyl tin in the presence of tris dibenzyl DBA dibenzyridine acetate dipalladium and in the presence of triphenyl arsenate and producing a compound. Here CH3, that is what? With this, a CC bond is forming, producing compound of this one. Let us discuss about the spider-like scaffold. To find a new lead compound, we need diverse structures. For this, best way to synthesize the variety of structures is preparing a spider-like molecules. And these spider-like molecules this spider-like molecule having a central body that is called as scaffold. The spider-like molecules having a central body, the scaffold, and it have the various arms, and these arms having active functional groups. These spider-like molecules having the central body, and these are various arms. The word substituents, and these various arms having active functional groups. The most commonly used scaffolds in medicinal chemistry are benzodiazepines. Examples for the scaffolds are benzodiazepines, This is a active functional group also. And hydentines, R2, R3, R4. Hydentines, these are benzodiazepines. Diazepine, hydentine. Next, lactams, beta lactam. R1, R2 substitution, R3, R4, R5, beta lactam, and they used scaffolds for the medicinal chemistry, and due to presence of these various active functional groups, these are interact with the receptors binding sites alike, and this is a receptor a receptor binding site, receptor binding sites, receptor binding sites. Here the binding areas, these are the binding areas in the receptors. In the presence of SC, screen compound libraries, like that. In presence of screen compound libraries, these scaffolds are binding to the binding sites of the receptor. The receptor binding sites. Here, these scaffolds, active functional groups are bind to the receptors binding sites. This is the interaction of receptors with the spider-like scaffolds. Next, high throughput screening, simply as a HTS, high throughput screening. In combinatorial synthesis, we get the large number of compounds in a short period, and biological testing of these compounds done quickly by the automatic method is called high throughput screening.